Okay, if it is not, so let's see about 7.5. So this is the last section we are going to study in chapter 7. This is about finding confidence intervals, but for variance, right? Okay. So variance, that means now we are going to estimate, sigma squared variance, population variance. So we are going to find an interval. Before going to do that, we are going to see one new thing, which is called a chi-square distribution. Like chi distribution, this also, a new distribution, but which has a degrees of freedom. Suppose if you have sample size n, then the degrees of freedom, say df, that is like a t distribution. Here also we take like n minus 1. Okay, so what are the properties we have for chi-square distribution? So this kind of curve, right? It's a continuous curve, but remember, if you look at all the curves, all the curves are um, right tail. Curve, right? What does it mean by that? That means all the curves are skewed to the right. Okay, so if you have all the curves have a heavy tail in the right side. If you look at the values of the chi-square values are always non-negative. That means all the values for chi-square distribution is bigger than or equals to 0. There's no negative value for chi-square. Okay. So these are the different pictures we have according to the given degrees of freedom. When you change your degrees of freedom, you will have a different shape of chi-square functions. Okay, so if you go through these, all the properties is there. The area under the curve, the full area of this chi-square distribution is always 1, like a normal distribution. The full area is always 1. So that is what this property says, right? The area under each chi-square distribution curve is equals to 1. So the chi-square values are greater than or equals to 0. The chi-square distribution is family of curves based on the degrees of freedom. So you should know the degrees of freedom. Then only we could, figure out the graph. The chi-square distributions are always positively skewed. Positively skewed means skewed to the right. Okay. Now let's see about the chi-square values. How do you find the chi-square values? Suppose if you know the right area, suppose say this is your chi-square curve. Suppose if you know the right area, say this is my right area. Say you know this area, say this is 0.05. If you know the right area, then we could find, the corresponding chi-square value. Okay. So how do you find this chi-square value? You could use the table to find this corresponding value. Remember, in the normal distribution, we have to have left area, right, to find the point from the table. But here we are going to look at the chi-square value for the right area. Okay. Suppose if you know the right area, then how do you find the chi-square value? Okay. Let me show you about that distribution table. You have to use the table number G, the one I have given. So look at the table G. Okay. So if you look at the graph here, you see now the area the area right side, if this is alpha, then the corresponding chi-square value is inside the table. Now in this particular example, my alpha is 0.05, right? So this is my right side area, alpha. So you have to look this value, um, in your table. So where is 0.05? 0.05 is somewhere here. Do you see? This is my alpha, right? Suppose if you know degrees of freedom, right? Say for example, say for this problem, say degrees of freedom, say my n is say 20. If n is 20, my degrees of freedom is going to be n minus 1, right? Which is 19. That means you have to look alpha 0.05 for 19. So if you look at 19, it is here. So 19 and 0.05 will give you what? 30.144, right? 30.144. So that is going to be my chi-square value. So therefore that is going to be 30.144. If you want, you could round up to a 1 decimal or 2 decimal, whatever maybe. So this is the way to find the right side. Okay, suppose what will happen if you know this area? Say this area is 0.05. Okay, suppose left area is 0.05, then what is my corresponding chi-square value for this point? How do you find that one? Remember, table always will give you right area, right? Therefore, if you want to find, the chi-square value for this point, that means you need to figure out the area, right area to this point. That means, you see now, where's my right area? So let me change the color. Okay, now you need to find the right area to this point. That means you need to know these all the area, right, for this point. So let's see who's telling what is the right area, what is the right side area to this point. One of you can tell me the answer. What is the right side area to this point?
Well, wouldn't it be 0.95?
Very good, 0.95. Why it is? Because the total area is always 1 for the curve, but you know the left area is 0.05. Therefore, the right side area is nothing but subtract 0.05 from 1, right? Because the total area is 1. You know the left area is 0.05. If you subtract, you will get the right side area, which is 0.95, right? Therefore, the right area is 0.95. Now you have to look for the table for 0.95, right? But I'm using the same degrees of freedom, same problem. So 0.95 is alpha is now 0.95 here. Then you have to look at 19, that is 10.117, right? So 10.117. You see now, my right point is here, that is 30.144. My left point is 10.177. Makes sense, right? Because this is my real line. The left point is always going to be smaller than the right point. All right. So make sure that you are getting correct value. So this is the way to find, the chi-square value. Okay. Do you have any questions? I believe you are good. Okay. So now we know how to find chi-square. Now let's move on. Now this is the thing we have to look at, right? Now the formula for the confidence interval for what? For the variance. Now we are finding the variance, right? You see now the variance confidence interval. Now let me write down this in interval notation. My left side point is now n minus 1, right? Then times little s squared over chi-squared right side point. This is your left interval point. Your right interval point is n minus 1, again a squared over chi-squared left side point. Hereafter I will use the letter R for right and letter L for left. Okay, so now this is my right side point, right? So this is the way to remember. You see, For both points, the numerators are same, right? N minus 1 times little s squared. But the denominators, you see, you have to switch the values. If you want to find the left point, put the right chi-squared value. If you want to find the right point, now plugging in the left chi-squared value. Okay? Why it is that? You know why we are switching? Because this is my interval, right? So you have to get the smaller value to the left point and the bigger value for the right point. But remember, this guy should be then bigger, right? If you want to make the fraction smaller, your denominator should be big, right? Right? Therefore, chi-square, the right side is always bigger, no? Than the left. So you have to switch in order to get the correct value. Okay? So now this is the way to find the interval. Unfortunately, we can't use the calculator for these kind of chi-square values, so you have to rely on your table. Okay. Once you know the interval for the variance, now it's very easy to find the standard deviation, right? Simply take the square root both sides. Then you will get the standard deviation. Therefore, the formula for the confidence interval for the standard deviation, little sigma, right, is given by simply take the square root both sides of your variance answer. Okay, so that means here my answer is simply the square root of your variance answer, and here the square root of your variance right endpoint. Okay. Again, we have some assumptions for the chi-square problem. So your random, the sample is random sample, and the population must be normally distributed. Okay, what is this little s here? What is little s? Yes. Remember, we are going to estimate always the population parameter from where? From the sample, right? So you have only sample, right? Therefore, this guy, little s squared, is my sample variance, right? So these all the values you see are coming from your sample. Little n is your sample size, little s squared is sample variance, and of course we find this chi-squared by using your sample or your sample what size, right? Because your chi-squared value depends on the degrees of freedom. Degrees of freedom coming from where? It is coming from your sample size. Therefore, the chi-squared values are always, chi-squared values are always depend on your sample size. Okay. Right. Let's look at this problem. Could you look at example 1? A study of 30 women found the standard deviation of their ages was 5.2 years. Find the 95% confidence interval of the variance. Assume that the variable is normally distributed. Okay. Right? The problem is now finding confidence interval for variance. Of course, we have only one formula for variance. So let me write down the formula. So the interval formula is now going to be n minus 1 s squared over chi-squared right, comma, n minus 1 s squared over chi-squared left. Now my task is to find these all values, right? Okay, read the problem and tell me. Let's see who's telling. What is this 30? Just one of you.
Yeah, your sample size.
Sample size, very good. N is 30. Then what is this 5.2?
Is it
It's
S?
standard deviation.
Sample standard deviation. Very good. Little s, right? Because these all the values are coming from your sample, right? Okay. So little s is now 5.2. So we know now these two, right? Only thing is now you had to figure out the chi-squared right and left. Okay, now let me draw a picture. My chi-squared picture is now like that. Oops. Okay, so now I have 95% confidence interval. That means your alpha is now going to be 5%. This side is, now you have two sides, okay? You need to find 2 points. This is my chi-squared left point. This is my chi-squared right point. Remember, these two areas are equal areas, so this is going to be my alpha over 2, and this area also alpha over 2. My alpha is now 5%, therefore my alpha over 2 is 2.5%. If you divide by 100, it should be 0.025, am I right? So this area also 0.025. Okay, so my middle area is now 95%. Okay, so now I know my right area of this point is 0.025. So let's look at the table. Where is 0.025? Oh yeah, 0.025 is there. But what is my degrees of freedom? Yes, my degrees of freedom, df, is simply n minus 1, but n is now 30, therefore 29. So my degrees of freedom is 29. Therefore, you have to look at 29 and 0.025. So 0.025 is here, 29. Let's go down, and yeah, 29 is here. 0.025. What is that column? Oh, the third column. Okay. So I need now 29. So it's going to be 45.722. Am I right? 45.722. Similarly, if you find my left side, oh, how do you find left side? Again, you have to subtract this guy from 1. So if you subtract, this guy from 1, you will get 0.975. So if you want to find the left point, you have to plug in this area, 0.975. So now I'm going to look at 0.975. Where is that? 0.975 is my third column, right? You see here, 0.975. So it's going to be my 29, which is 16.047. 16.047. Okay, so these are the two values. That's it. Plugging all the values now here, you will get the answer. Therefore, my confidence interval CI is going to be, I'm just using this formula and plugging the values, right? And minus 1 is now 29 times S is 5.2, therefore S squared is 5.2 squared over chi-squared right side point is, I got 45.722. Then if you move to your right hand point for the interval, again 29 times 5.2 squared over, now your left hand point is 16.047. That's it. So now take your calculator and simplify.
How many decimal places do we write the notations in?
You could write in 1 decimal or maybe 2. So make sure that, yeah, you are getting, I already worked here, right? So look at the answer. So make sure that we are plugging the correct value, okay? So remember, always you need to find the two values, right? Chi-square left and right. So this is my alpha over 2. This area is alpha over 2. And this is my chi-squared left point. This is my chi-squared right point. So always you have to plug in the right area to that point to find this corresponding chi-squared value. Okay. So once you know confidence interval for the variance, then take the square root of both side answers. Then you will get the standard deviation confidence interval you see here. Okay. I believe everyone Understood. So if you have any question, please ask me. Okay, I believe you are good. Right. Now let's move to the second example. Oh, you see now second example. We don't have sample standard deviation. Instead, we have the data values, right? Right? Okay, then how are we going to approach this problem? Any suggestion? First of all, you should know these variables, right? The question is what? Read the problem. What is the question? Find the 90% confidence interval for the variance. Okay, again finding variance. For that reason, we need to know those three numbers, right? N squared and chi-squared left and right. Okay, but unfortunately, we don't know little s. We have to find the little s. How do you find little s? Sample standard deviation or little s squared. How do you find? You are given the data values, right? Yeah, you have to feed these values into your calculator and find the sample standard deviation or sample variance. Okay, so you need to figure out that. So could you plug in these all values into your calculator and check whether you are getting correct answer? So here you see my work. The solutions are given, right? So how many data points are given? 1, 2, 3, 4, 5. There are 10 values here, right? Therefore, my sample size is now 10. So degrees of freedom is 10 minus 1, which is 9. So now what is my chi-square values? Say this is my chi-square left. This is my chi-square right. But you know, what is my alpha? Yes, 90% confidence interval. Therefore, 100 minus 90, 10, right? Therefore, my alpha is 10%. Divide this by 2 to put both sides. So this side is 5%. That is 0.05. So that side also 0.05 area, right? Now make sure that you are getting these two correct values from the table. Chi-squared right, 3.325. Chi-squared left is 16.919. Now you know how to find, right? Okay. Okay, make sure that you are getting those two numbers. Okay, the thing is now finding little s squared. So in your work, it says that my little s squared is 16.9. Could you check that? Take your calculator and feed the data values. So on stats, sorry. So stats, edit. I'm going to clear these all. So I'm going to enter all 10 values. 10, 5, 12, 19, 10, 5, 12, 11, 13, 15, 19, 15, 19, 18, 14, and 16, right? So I got 10 values. Okay. So now you could calculate the value, right? So again, go to stat and cal. One was stat. Okay. Oh, you see now. So which one is I want now? I want a little sx. That is my sample standard deviation 4.11. So my sample standard deviation is 4.11. Therefore, my s squared is 4.11 squared. What is 4.11 squared? That is 16.9, one decimal answer. That is why you have 16.9 here. So make sense? One decimal. Or if you want, you could make 8, 9. No problem. Right? So you are plugging those values. That's it. And you will get the interval. So this answer is confidence interval for what? 4 sigma squared. This answer is confidence interval 4 sigma. Okay. So I believe these are the exercises I have put here. So you could try all the problems. Okay. So I'm giving now 5 minutes to, think about the things, whatever you learned today. And if you want, you could discuss with you guys among you, and you can, mute off and you can discuss with your colleagues if you want. So, yes,
Dr. Raj.
yes.
To find what you divide the
Who's speaking? Just a minute.
freedom in the
Who's speaking?
Shemaiah.
Shemaiah. Okay, go ahead, Shemaiah.
To find what you divide the 10 minus 1 multiplied by this sample size squared, how do you find that again?
Oh, so that is go to the, you need to first fill the data values, right? You know that, right?
No, I'm talking about with the table. What do you do with the table?
Oh, that is to find the chi-square value.
Yeah.
Yeah, not for the chi-square value, right and left, right? These two values, no? You are asking about these two, right?
Yeah.
Okay, so now how do you find the chi-square right side? You need to know the right side area then, this area. Okay?
Okay.
So, what is that area? 0.05. It is given here. You know the degrees of freedom, which is 9, right?
Mm-hmm.
Yes. Okay, now go to the table, degrees of freedom 9 and area is 0.05. The area is,
Okay.
yeah, 0.05 is here, degrees is 9. Are you getting that value?
Yes, I got you now.
Yeah, good. Any questions? So then why don't you try these problems? Of course, you have the video link, right? So you could click the video link and watch the the video. I have given this the list of the video links. You can just click on that and just listen to that. Okay, so we are done with confidence interval, right? So for the summary, under this chapter 7, we had first the confidence interval for population mean, mu, right? We had that. There are two cases under here. One is what? One is if you know standard deviation or variance is known. Then second case what? If you do not know. So we have two formulas, right? Go and check those. Then we had what? Then we had confidence interval for the sample proportion little p, right? For this is only one formula we had. Then today we had the confidence interval for the population variance, which is sigma squared, right? Altogether, 1, 2, 3, 4. There are 4 formulas you have to look at. Okay? Make sure that you understand everything. If there is any, do you have any question? If there is not, we will move to chapter 8.
I have one more question.
Yes, go ahead.
Okay, so it's back with the chi-squared thing that I asked you about earlier. So like with 0.05 being what you use to find the 16.919, why isn't it the same number on the other side?
Because the chi-square distribution is skewed, not symmetric. One
Okay.
side is different than the other, right?
Mm-hmm.
Yeah, that's the reason. But for the normal distribution, the graph is symmetric, very nice shape, bell shape, right? That's what for the normal distribution you had the same number with the negative sign, but here you will have different numbers. Does that make sense?
So which number did you use to find the 3.325?
Where is that number? Oh, this is okay. So you see now this value we are talking about, right?
Yes.
Okay, this is my chi-square left point, this point, right? How do you find that point? Always remember, if you want to find that point, you have to plug in the right area to that point. Okay? So then what is the right side area to that point?
0.05.
No. My mouse is not working.
No.
It's not. You see now, this is the point, right? I'm talking about.
Yes.
That means you have to find the area to that point. Right side of area, this all.
Oh, okay. I got you now.
Okay, it is 0.95, right?
Oh, okay. So, okay. Okay.
Good. Okay. So now let's move to chapter 8. So this is about the hypothesis testing. So I have put the video link, and if you want, you can click here, or you could check, the uploaded file there, and you will see a lot of links. And you could check 8.1, the introduction to hypothesis testing. And you will see there, in detail. Okay, what is hypothesis in terms of statistics? Suppose you have some assumption, right, based on your population value. You are guessing some kind of value, or you have some kind of doubts whether your population value may be this much or that. So in that case, you have to check whether your assumption is correct or not, right? These kind of things are called, testing statistical hypothesis. Wait. Okay, so now there are two things we have to understand here. When you perform statistical hypothesis testing, so we have to have always two things. One is called the null hypothesis, another one is alternate hypothesis. So different statisticians use several, the notations, and here I'm using H naught for my null hypothesis, and I'm using H1 for my alternate hypothesis. This alternate hypothesis is always going to be your assumption. Whatever you assume, right, this is going to be your alternate hypothesis, okay? Right, there are several types of hypotheses available. There are, of course, three types. Three types of, hypotheses are there. The first one is called two-tail, another one is right tail, and the last one is left tail, right? Look at these examples. You are suspecting, you have some doubt about your population mean, right? K is just a value, maybe any number, maybe 50, 10, 12, whatever, maybe a fixed number. So you are thinking your assumption for this problem, okay? For this one, your assumption, you have some kind of doubt about your, your population mean, right? So you are just, checking whether your assumption is correct. So you are thinking that your, the population mean may not be 50. That is your assumption. Then you are going to check whether this assumption is correct. Before going to check your assumptions whether correct or wrong, first of all, you have to set up a hypothesis testing. So you have to set up like H0 and H1, okay? Your H1 is always going to be your assumption. So in this particular problem, my K value, K is now 50, all right? Then your null hypothesis, this is your null hypothesis, H0. Your null hypothesis always will have zero, equal sign. Look at all three cases. For your null hypothesis, H naught always have the equal sign, right? For the alternate, maybe different kind of, you know, uh, assumptions you have here. If you look at the first, this is called two-tail. If you have two-tail hypothesis, your alternate hypothesis always will have not equal sign. Okay? Look at this one. For the right tail test, your alternate hypothesis says you have some kind of doubt. Your population mean is you are thinking like bigger than 50, right? For like this, bigger than 50. In this case, remember bigger than means what? If you have a curve, bigger than is always right side, right? That is why you have right tail test. In the right tail test, you will have always greater than sign or bigger than sign. For the left tail test, you have less than sign, right? Left side. This is my left, right? Therefore, based on your, the assumption, you could set up your statistical hypothesis. Okay. So first you have to fix your, H1, whether it is not equal or bigger than or less than. According to that, we are going to perform our test, right? So these all three scenarios are checking about your mean values, right? If you look at these three examples, these all are talking about what? What is little p means? Yes, one of you can give me the answer. What is little p? This is population parameter, right? Mu means mean, right? Then p means what? Yes, George?
I thought it was successes,
Oh,
but I'm thinking it's
I need to
different.
know. So what are the population parameters we use? Yes, one of you can give me the answer. What are the population parameters we have? Mu. Mu means what? The population mean. Then we have sigma squared, population variance. Then one more, little p. This is population proportion, right? Yeah, success, you are correct. But we use this, statistical term, right? Proportion. So these are the three main parameters, population parameters we have, okay? So we are going to look at these three cases here in the testing hypothesis cases. So now you are suspecting whether your population proportion value is not equals to k, right? So not equal means always two sides, maybe left, maybe right. So you take two sides. That is called two tails. You have both side tails. Now look at this. Here you are suspecting that your population parameter proportion is bigger than k. So this is right tail. And again, this is left tail. Okay? Right. If this is the case now, could you read the problem one by one? This example states the null and alternate hypothesis for each conjecture. Conjecture means kind of assumption, right? Okay. Now what is your task? Your task is to set up like this hypothesis testing. You need to tell me now, for example, this one, right? You need to tell me what are the hypotheses for H0 and H1. You need to tell me like this. You have to set up, okay? You know the value now. K value is given here, 30 for this problem. Okay. Okay. Let me do the first one. We are going to try remaining all. Okay. What are the population parameters given in this problem? What kind of parameter they are talking about?
Gambling and young people.
Okay, but you have to tell me the population parameter, either mu or sigma squared or the proportion.
Is it proportion?
Is it mu?
It is mean, right? So in average, they are talking about the average 30. Okay, so it is the average. Okay, so then what is her guess? Her guess is she's thinking that the mu is more than 30, right? That means your assumption is always going to be your H1. So mu more than means bigger than 30, right? Then of course your null hypothesis is always equal sign. So this is the setup for the first one. Okay. Now like that, could you think about the second one?
Would be mu.
Yeah, average. Very good. That also mu, right? Okay, go ahead.
Huh?
So would it be M less than 120? Is that what you're asking for number 2?
Yes. So again, we are going to use mu, right? Yeah, mu. Yeah. So this is for number 1. Again, for number 2, my H0 and H1, they are talking about again the population mean mu. Now it is 120. So, but this is they are talking about what? Lower,
They're
right?
predicting the lower score. So it's going to be M's less than 120.
Less than 120. Very good. So that means, could you explain what kind of test this is? Is that right, left, or two-tailed for the first one? First one is going to be, if you see
Right
greater
tail.
than sign, right tail. Yes, this is right tail test. This guy, less than sign, right? Therefore,
Left. Yeah.
Left tail.
left, yes, left tail. Very good. Go ahead. Number 3.
Mu.
Are they talking? Oh, yes, they're talking about average again. Mu, very good. So my H0, H1. So my assumption is going to be H1. So what is my assumption now? The teacher feels that if an online text is used for a course instead of the hard book, it may change the student's score on the final exam. In the past, the average final exam score is 83, right? Now, what is her thinking? What is her thinking? That
And it will
is
not equal 83.
not equal. Very good. She is thinking that the score may change. What does mean by change means? Maybe less than, maybe greater than to 82, right? 83. Therefore, it is going to be now not equal, right? Maybe any number, but for sure, she is thinking that it is not equals to 83. So then, of course, this is going to be 83. That makes sense?
Yes.
So that means this is going to be what kind of test?
Two-tailed.
Two-tailed. Very good. That's it. Okay then. Oh, now you see this one? What kind of parameter?
The proportion.
Proportion. Very good. If you have the number, talking about regarding to the number of people, it's going to be proportion. Okay. So that means number 4 is about the proportion. H0 and H1. So they are talking about the little p now. Right? 64% means how much in number? 0.64. Oh, why I'm putting equal sign?
Should be greater than.
Oh, let's see. Yeah, more than means, yeah, greater than. Very good. It should be greater than. So this should be equal, right?
So will H not always be equal to
Yes,
something?
H0 is always equal. Yes. Only H1 will change according to, your assumption. Okay, good. So again, this is going to be right tail test. Okay, again going to be proportion because they are talking about the number of people in America. So okay, what kind of? Are they talking about less or greater or not equal?
Not equal.
Not equal. They don't talk about less or greater. That means they're talking about unequal. So it's going to be 0.25. Okay, the last one. These all proportion. If you see percentage of something is proportion. Less than, right? So it's going to be. Okay. So this is the way to set up hypothesis testing. Two-tail. This is left, right?